Hi everyone, I'm back again. I'm here to do LeetCode problem number 621, task scheduler. So let's get started. Let's read the problem. Given a characters array tasks representing the tasks a CPU needs to do, where each letter represents a different task. Tasks could be done in any order. Each task is done in 1 unit of time. For each unit of time, the CPU could complete either one task or just be idle. However, there is a non-negative integer n that represents the cooldown period between two same tasks, the same letter in the array. That is that there must be at least n units of time between any two same tasks. Return the least number of units of time that the CPU will take to finish all the given tasks. Okay, this right here is a lot. It's a very rather convoluted problem description, but the problem is not hard. Let's go over this example right here. So you have A, B, 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 and the cooldown period is 2. Basically, what you're trying to do is return the least number of units of time that the CPU will take to finish all the given tasks. You want to order these tasks and do them in a way that the CPU finished all of the tasks in the least amount of time. So this n equals 2 cooldown period means that whenever you have tasks that are the same type, right, you need to let them sit. Let the two tasks that are of the same type have the cooldown period first before you can do that same task again. I'll give you this example, right? You start with an A, okay? Well, you can do a B or let the CPU remain idle, but it has to be 2 units of time before you can do another A task, right? So it's A, the task A has kicked off, right? And then there's unit 1, 2, and then you can do another A, right? 1, 2, and another A, right? Same with B. You kicked off task B, right? 2 units of cooldown before you can do another B. So it's 1, 2 before you can do another B. 1, 2 before you can do another B. So at the end of the day, given this configuration of tasks, the best that the CPU can do is 8 units of time, right? So you do an A, B, let it remain idle, A, B, let it remain idle, and A, B. And so that gives you the answer. And then it gives you this one, where there is no cooldown period. Well, you just get either this configuration, or this configuration, but each configuration gives you a time of 6. And here's another crazy one, n equals 2, the output is 16, and here's the solution. So with this problem, it's considered a medium problem. This is not a hard problem, but it was definitely very tricky. And the solution I'm going to present is the one that I found from LeetCode, which I really like. I think I've always learned a lot from him. So thank you. That this is where the citation, I'm giving you the citation, how I got my algorithm. It makes a lot of sense to me. So let's start doing it. As always, I love to write down the constraints first before we start doing anything. So 1 is less than or equal to task.length, which is less than or equal to 10 to the 4th. Then you have tasks. I is uppercase English letters, and then you also have that the integer n is in the range 0 to 100. So from these constraints, you know that the tasks you are given can be rather lengthy, all the way up to 10 to the 4th. Each value within the tasks list is uppercase English letters, so that's from A to Z. The integer n is in the range 0 to 100. The integer n, the cooldown period, is anywhere from 0 to 100, right? So from this solution already, you know there's some kind of brute force approach it's just not going to work. These constraints are, once you look at the extremes, they can get very extreme. So you have to be a bit sharper with the way that you code the algorithm. So I originally thought that this was a dynamic programming problem. That's what I originally thought, but this is not a dynamic programming problem. This could be solved in a multitude of ways. This is an array, hash table, greedy, sorting, heap, priority queue, or counting problem. So there's a multitude of different ways to solve this problem, right? You have array, hash table, greedy, sorting, heap, priority queue, or counting problem. So in this approach that I'm going to demonstrate here, we're going to go with a heap and priority queue solution, okay? So let's go over the approach. The basic idea is that, you want to create a heap, a max heap that will hold the frequencies of all the tasks. And the key insight is that the task that appears the most is the one that you want to schedule first, right? That way, such that you always, that is the way to get the optimal solution, is if you count the frequency of all the tasks and schedule the one that appears the most frequently first, and then you go down the line. So the heap, the max heap, is going to hold the count of the outstanding tasks that we have to do, and the priority queue is used to determine which tasks you should execute at that precise moment. Is my understanding. Let me think about that for a minute. Give me 1 second. Yeah. So I take that back. The heap is always where you decide which tasks that you can execute, and then the priority queue is going to be used to hold the tasks over the cooldown period. And once the tasks, are done cooling down, the tasks of the same type, you can bring them back from the priority queue back to the heap where they can be executed again. Okay, so let's get started. Define a max heap that will hold the count of all the tasks that will hold the count of all the tasks grouped by tasks, by task types. Okay, you have to define a time variable that will serve as the answer. Define a priority queue that will hold two values: the count of tasks, as well as the time when the task can be brought back from the cooldown period and be executed again. So then the algorithm is that, 1 second, while the max heap and the priority queue are not empty, do the following. One, update the max heap and see if any tasks are executed? If so, move the task into the priority queue. Into the priority queue. And the second task is that, update the priority queue when a task has reached the end of its cooldown period, and if there are still tasks of the same type, move the task counts back to the max heap, right? And then I think you just have to return the time, which is the answer. So let's try to do this. So define a max heap, right? So I always get confused on this. So that will hold the count of all the task group by task type. Okay, so the first thing we need to do is in Python, there's this thing from the collections framework that will count things for you. So let me call it frequency equals counter task, right? This counter from the collections framework will count the frequency of all your items within a collection. Okay, so now let's define the max heap equals, in Python you only have a min heap, so to get a max heap you have to negate all the values, right? Negative count for count in freq dot values, right? And then now that you have a list of values, you have to heap q and heapify heap q dot heapify max heap. Okay, so that's that first part. You have to define a time variable. You have to define a priority queue. So I'm going to pq equals dec. Okay, so that's what I'm going to do. While max heap or pq, while they're both not, they still have values in them, time plus equal 1. Okay, and then if max heap, right? If the max heap is there's still values in there, right? If max heap, update the max heap to see if any tasks are executed. If so, move the task into the priority queue. Okay, so how about this? How about count you want equals 1 plus heap q dot heap pop. Give me 1 second. I'll be right back. I'm going to take a look at the documentation quickly. Okay, I'm back. I forgot. I always forget this syntax, right? Count equals 1 plus, when you've negated the values, if you want to decrease it by 1, you have to add 1 to it. So heap q dot heap pop max heap, right? And the if count, then you add it to the this is where you add it to the priority queue. Pq dot append count, and you do time plus count, I think. Okay, let me check. Hang on. Okay, so right here, this is time plus n, right? So you want to get the current time and then add it to the add it to the cooldown period so that you know that once time hits this hits time plus n, you know that you can bring this task back from the priority queue and add it back to the max heap. Okay, so that's max heap, right? And then now is if PQ and PQ of 0 of 1 equals time, then you bring it back from the priority queue. So then you do a give me 1 second. Heap q dot heap push max heap, and then this is where it gets kind of tricky. PQ dot pop left, and then you just want the count, so you would do a 0. And if I'm not mistaken, this is it. I think this is the answer. Okay. Let me submit it one more time. Okay, well, it definitely worked. I'm going to submit it one more time, and I'm going to just grab the time and space complexity right here. This one's a little bit complicated, so not complicated, but it's a lot to remember. So this is what I'm going to just paste it right here. So when you're working with the max heap, the time complexity is O of log n. It's actually O of log 26 to be more precise. The time complexity is O of n times m, where n is the size of the task and m is the cooldown period, right? You have 3 tasks, and if the cooldown period is 2, then that means you have 3 times 2, which is 6 in total time complexity, which makes sense. And the space complexity is O of n, where the max heap and the queue can store at most n values, where n is once again the length of the tasks itself. Okay, let me submit this one more time and see the space and the runtime and the memory. Okay, well, I have no idea why it's a little low right now, but this is definitely how you solve this problem, and it's an interesting problem. It's not the easiest problem, but I learned a lot from it. So thank you very much, everyone. I'll see you at the next one.